Now that we've looked at solving exponential equations, let's look at solving logarithmic equations. So here I have 6 plus natural log of x is equal to 10. I'd like to solve this for x. Now, our go-to strategy when we had exponential functions that we were trying to solve for x, we wanted to get the exponent by itself, then apply logarithms. Here it's going to be a little bit different, but a similar twist. So our goal in this case is to get the logarithm by itself. If there's just one, get the logarithm by itself. So that means I subtract 6 from both sides. I have natural log of x is equal to 4. Now, once I have the logarithm by itself, if it is equal to a number, we'd like to figure out how do I get rid of the logs. So remember, we're able to convert logs to exponents, and that is going to be our go-to technique here. So writing this as an exponent form, my base is e, so I have e raised to the 4th is equal to x. And that is my answer. So if we have a logarithm equal to a number, when it's just one of them by itself, we can now change that to exponential form. Here, if I have two logarithms that are equal to each other, if the bases are the same, well, the insides must also be the same. Right? If I have, for instance, say log of x is equal to log of 10, the only way for these two to be equal to each other is if the inside, this x is equal to 10. So if I have this, I'm just going to set the two logarithms equal to each other, or set the insides equal to each other. So I have x squared is equal to 2x plus 3. So just set the insides equal. Now I'm solving this because it's just a quadratic equation. So I can move everything over to one side, subtract these over. So I have x squared minus 2x minus 3 is equal to 0. So to solve a quadratic, we set equal to 0, and then we can factor or use the quadratic formula. So this factors as x minus 3 times x plus 1 is equal to 0. So set each of these equal to 0, we see x is equal to 3 and negative 1. And those are our answers here. So two logarithms equal to each other, we just simply set the insides equal. Over here is a little bit of a tricky one now. Now we have log base 2 of 2 plus log base 2 of 3x minus 5 is equal to 3. Now, you might be thinking, well, it's kind of like this one, right? I'm trying to eventually turn this into exponential form, but we have to also remember the rules that we had about logarithms to see how do I change this into a single logarithm. Here it was just a single logarithm, so I could do it. I need to have a single logarithm. So the rule said that if I have addition on the outside, that becomes multiplication on the inside. So this becomes log base 2 of 2 times 3x minus 5 is equal to 3. But I'm just going to distribute this inside. I have 6x minus 10. So I have log base 2 of 6x minus 10. Now I have the logarithm by itself. There's only one of them. That equals a number. So my go-to strategy is to convert this into exponential form. So I have 2 to the third is equal to 6x minus 10. So now I solve for x. So 2 to the third is equal to 8 is equal to 6x minus 10. Add 10, so I have 18 is equal to 6x. So x is equal to 3. Now, that is my answer for now. But this is a really important step, is that if you combined logs into a single log, you must check your answer. This is an important step. So if we ever use any of those, I turn two logs into one, I combine them, or even if I bring a number in front into an exponent, we have to check our answers. So here, what happened was I have these two logs that I added. I combined them into a single log. I need to check my answer. What we're checking for is the inside of logs positive. This is what we're looking for. If I check my answer and I realize that the inside of my log is negative, then that is not an okay answer. But as long as it's positive, then that's great. I have found the answer that I needed to. So here, let's check this. So what this looks like, what we're checking for, is I'm plugging x equals 3 inside there. So I'm trying to see log base 2 of 2 plus log base 2. I plug in 3, I'm going to get 9 minus 5 is equal to 3. I am 9 minus 5. I'm not trying to verify that the math is correct. I'm trying to see, is the inside of the logs positive? So here I have the inside is 2. Here I have the inside is 4. They're both positive. So in this case, both of these are positive. So what that tells me, x equals 3 is the solution. So what happens is sometimes we might get no solutions. Sometimes we might get more than one. We check them, maybe only one of them works. Sometimes we might have more than one solution and both of them work. So we just have to check our answer to check for positiveness inside the logs. And then that's the only added step we have whenever we combine our logarithms using one of those rules.